review. So hopefully you've looked at parts 1 and 2, and now you're ready to finish up with these last 12 problems. So let's take a look at problem number 24. So if a pebble is dropped into a pond in the shape of an ellipse at the location of one of the focus, the waves will converge at the location of the other focus. If the pond has a major axis of 40 feet, a minor axis of 24 feet, how far apart are the foci? So just kind of get a visual here of what that looks like with an ellipse. Your major axis is from your center to one um, vertice on the longest axis, okay? And so we know that is 40. Then we have our minor axis, which goes from the center to one of the vertices. And again, that's on the shorter axis. We know that is 24 feet. Now, I want you to remember that our foci are along the major axis. And we use this formula to find it. Now, you may look at that formula and say, ooh, you got it wrong, right? There's a minus there. And it's really close to the Pythagorean theorem. The Pythagorean theorem it looks exactly like this, but it has a plus there. But our foci are found, our C tells us how far our foci are away from the center. Okay, so let's figure out A here is the length of our major axis. So if our major axis let's go ahead and substitute in the A here, which represents the major axis, is 40. And B here, which represents the minor axis, that's 24. And then I want you to use your calculator. So 40 squared is 40 times 40. That gives me 1600 minus, and then 24 squared gives me 576. And then we're going to subtract those. So 1600 minus 576 gives me 1024. Now I'm going to, because this is equal to c squared, I'm going to have to take the square root here of 1024. And the square root here of 1024 would be 32. So I really want you to highlight that formula for yourself so that you can have it in your notes. Because remember, you want to have this review right beside you as you're taking the test. When you look at problem number 24 on the test, I want you to look at problem 24 on the review, and I want you to look at the same formulas, think about using those. So hopefully that helps on number 24. Look at number 25. It's a freebie. You guys know I love freebies. So take a look and make sure you get the answer here. We've given the answer for number 25. It's a freebie. It was actually from a lesson that we skipped over hyperbolas. And so I want you to make sure you get it right. So friends, please, please get the freebie right. All right, let's keep going on number 26 here. Ah, yes, another freebie. So make sure on number 26 that you do get the answer right here. All right, so let's go ahead and look at number 27. Now, you know, any question on the matrices here, I want to use that Desmos matrix calculator. How do you get there? Well, I seem to never remember the website. So friends, here's what I do. I Google literally these words, Desmos matrix calculator. That's exactly what I type in Google, and it brings up the Desmos matrix calculator. So let me pull it up here for us so that we can take a look at it as we're working through this problem. All right, here we are with our matrix problem. I've got my Desmos calculator there, my matrix calculator. Let's take a look at the problem though first. It said, given that A is this matrix and C is this matrix, and we know A plus B equals C. So we want to find B. So think about your equation first before we do anything with the matrix calculator. In order to get B by itself, I would have to subtract A. So that's what we're going to do with our matrices is we're going to do C minus A. Now, we're going to have to tell the calculator what we want these matrices to be. So we need to tell it what C is. We need to tell it what A is. Let's do that here real quick so that we can see. So I want to put in a new matrix. Now, but this matrix, I don't want it, let's see, let's make it C here. And we want it to be a new matrix. So C, I want you to type it in, 10, -4. Notice you're going to have to add a couple of more columns. And then I'm going to type in the rest of the components, 5 and -8. Friends, I'm just using my right arrow to go to each one of these so you can see it. And then be sure and press enter when you get finished typing in C. Now A, we haven't finished that. We need to go back in and tell it A. So I've got to add a couple more columns. And let me type in the elements of A, -2, 5, 8, -6, 0, -3, 1, and 10. And then be sure and press return. Now, my last step then, I want to tell the calculator what I want, and I want C minus A. So use your letters over here, C minus A. And friends, there's your answer right there. The calculator did all of the work for you. So B is going to be this matrix you see here, which is 12, -9, -3, -2, and then 3, 4, -3, -3. And there you go. That's how you work smarter, not harder, right? You use your matrix calculator to do the work. Now, do you have to do some parts of it? Absolutely. You've got to put it in correctly. But you can do this. You definitely, definitely can do this. All right. I'm going to go ahead and press enter here only because we are going to be looking at problem number 29, also with the matrix. Oh, sorry, problem number 28, also with the matrix calculator. So I'm going to leave it up here. So what we have right now, this is for that problem. I want you to use the clear all button because that will reset your matrix calculator um, so that we can redefine A and B. So here's what I want you to do. Take a minute and let's put in A and B. So we're going to tell it A equals a new matrix. This matrix is a 2 by 2. So let's type it in. 5, -2, 3, 0. And then press enter. And then let's do B as a new matrix. And let's type in the elements of B. 2, -1, 6, and -3. And again, we'll press enter. Now, remember what this question's asking for. What is A times B? So friends, let's just type in A times B. And there's my answer. The calculator found it. So my answer for A times B And again, let's make a little note. This is we're using the Desmos matrix calculator. And we get that A times B equals -2, 1, and 6, -3. Really, really, really use your Desmos calculator on the final exam. Okay. We we want you to use it. Okay, friends, let's stay on the Desmos calculator here with number 29, which asks us if this matrix has an inverse. Excuse me, my cats thought she needed to be a part of our recording here. So let me get that straightened up here. There we go. All right. So we're going to stay here, but remember on my calculator, let's go ahead and clear all. And let's put in this matrix. So we're going to say the A equals a new matrix. And let's type in the elements 5, -4, 2, and 1. Be sure and press enter here. And now we want to ask it for the inverse. So we're going to do INF of matrix A. And so, friends, those are some pretty ugly decimals, but do you see that little button right beside it? That will convert these to some fractions, which are much, much nicer. So here's the deal. The question says, does it have an inverse? Well, the calculator just found it. So yes, it has an inverse. The inverse of A, I wrote it in words, but I also wrote it with symbols. And then you can copy down these fractions. Now, the final exam's probably going to have them in fraction form, but that's just a click of the button for you, okay? You definitely can see that as well and use that. Pretty simple with that Desmos matrix calculator, right? Okay, we're going to stay put here. I'm going to switch and then we'll switch right back because we are going to use the Desmos calculator for this problem as well. But let's set it up on our paper here. This asks us for what is the solution of the system. Notice that, and I'll tell you, the question on the test is not going to give you a method. So you get your choice. I personally would use the Desmos matrix calculator. But let's get it set up with a matrix first, friends. Remember, when you write a matrix for an equation or a system of equations, you're only using the coefficients. So we have 5, -1, 1, and 4. Notice where I got those in front, the numbers in front of each of the variables here. For equation 2, that would be 1, 2, -1, and 5. Again, sorry about my cat needing to be part of our recording. Then I have 2, 3, -3, and 5. So here's my matrix. Now I'm going to switch back over. Let's get this one entered into our Desmos calculator. There we are. And let's clear all as we did before. We're going to put in this matrix as a new matrix. And we've got 3 rows and 4 columns. So let's put in all of these elements. 5, -1, 1, 4, 1, 2, -1, and 5. Okay. And again, I apologize. Hopefully she's not going to interrupt us here again. And 5. Then I've got 2 and 3, -3, and 5. Go ahead and enter there. And then here's your key notation I want you to make sure you use. Write that down on your note sheet. It's the RREF form. RREF of matrix A. Now, what that gives us is this matrix. Okay. And your answers are here now in the last column in alphabetical order. So this means that X is 1, Y is 3, and Z is 2. And then you can write it as an ordered triple. But make sure you've got that notation. That's how you've got to tell the calculator, hey, I want the answer, and this is how you get it for me. Okay. All right, friends, let's switch back over to our review. We've got just a few more to go. We're told, let's look at the word problem here, number 31. A bakery sells muffins for $3.50 each, a beverage for $1.75, a class purchase 32 items, spends a total of $94.50. So let's define our variables. I'm going to do M as a muffin, and I'm going to do a B as a beverage. So my first equation, let's deal with the 32 items. So my muffins plus my beverages have to be 32. And then the second equation, let's deal with the price. So my muffins sell for 3.50, the beverages are 175, and that equals 94.50. So there's my define my variables. Here's my write my system of equations. And the last one asks us to write it as a matrix equation. So I've got 1, 1, 32. Then I've got 350, 175, and 94.50. Okay, so now let's go to our matrix calculator so we can find the determinant of this matrix. Okay, switching back over. Gonna do a clear all here because I'm gonna put in a new matrix. Let's call it A. And it is 2 rows and 3 columns. So I'm going to create one more column there. And let's type in the elements 1, 1, 32, and 350, 175, and 94.50. There we go. Okay, now write this for your review so you know. We're going to ask the matrix calculator for DET of A, the determinant of matrix A, and look at it, it's giving me a problem. Why is it giving me a problem? It's giving me an error. Oh, but did you see when I hovered over there and I clicked on it? It told me that this doesn't have a determinant because this is not a square matrix. Now, if you remember, a square matrix has the same number of rows as it does columns. Therefore, this can't have a determinant because this has more columns than it does rows. That's why it won't work. Okay, now we've got a part C here. And this should not say the number of children and adults, the number of muffins and beverages. Not at the park, but that were sold. So let's see what that does to help me here. So back on our matrix calculator now, let's go ahead and ask it to do RREF. Now, if you're asking yourself, what does that mean? That's row echelon form is what that stands for. I'm putting it in my notes so I know which option to choose. I want row echelon form, RREF, of matrix A. And remember, our calculator tells us now we've got 1, 0, 22, 0, 1, 10. And remember, our answers are in the last column. So remember, my muffin, right, came first, my muffin, then my beverage. So this is telling me my muffin is 22 and my beverage is 10. Now, those aren't in alphabetical order, and you're right, but I want you to remember what our original equation was. Okay, so when I took the 1 and I put it here, and I took the 1 and I put it there, and I put the 32 there, then this is telling me what was 1 here before, which was the muffins, is 22, and my beverages are 10. Okay, so I hope that helps. I'm going to switch away from our matrix calculator here to look at problem number 32. We've got about 3 more to go, 3 or 4 more to go. You're doing great. Remember, this is going to be perfect to have alongside of you when you're working on the test. So look at number 32. It says, combine the like terms. Okay, we can do this, friends. Let's go ahead and distribute here. So I'm doing 6x over 3 minus 6 times 5, which would be 30. Be really careful when you distribute this 7 halves. You've got to distribute negative 7 halves. So you've got negative 7 halves x minus, and then I've got 14 over 10. Did you see how I multiplied the numerators and then I multiplied the denominators? Yeah. Okay, let's take a look. This is going to be 2x minus 30 minus 7 halves x minus 7 fifths. Ugh, that does not look pretty at all. Okay, no worries. You're going to be able to use a calculator to help you with these fractions. So let's take a look. Now we're back on the Desmos matrix calculator. You may be going, why do I need a matrix calculator for this problem? You don't, but it's a calculator. So let's use it, right? I'm going to combine these two terms that have x's in them. To do that, I'm going to have to do 2 minus 7 halves. Watch how I type it in this calculator and let the calculator do the hard work. 2 minus, and then I want you to put in parentheses 7 divided by 2. And then you can close the parentheses or not. The calculator understands it. You're going to press enter. Beautiful little fraction button there. Let the calculator do that for you. So that tells me I actually have negative 3 halves x. Now let's do the same for the two terms that didn't have an x with them. So I have negative 30 minus 7 fifths. Again, negative 30 minus 7 divided by 5. And there you go. Again, click that little fraction button and we get negative 157 over 5. So it's kind of a win-win. If the multiple choice question has a decimal there, you have the answer. If it doesn't, you can click that little fraction button and you got a really, really nice way of converting those back to the fraction. So let's switch over back. We're on number 33 now. So we have the function x squared. The graph of f of x is translated 5 to the right and down 2. What is the new function rule? All right, friends. So let's talk about, we've had some work with this before, and I've left some blanks in here, created a lot of space. Remember, left and right translations go inside the parentheses. So because this is right 5 units, it's minus 5. Now you may be saying, "Ah, minus? I thought right would be plus." Well, it normally would be. Except when it's inside of a parentheses, we have to do the opposite of what we normally would think. So I want you to make a little note to yourself that it's right because of the minus. If that were a plus, it's going left. Then we're going down 2. So down or up is outside of the parentheses, and it is what you normally would think. So you normally would think down means 2. So Minus means down. So we would put -2 here. Okay. Again, make a note to yourself that if those change, if you're going left, got to put a plus there. If you're going up, you got to put a plus there. Keep those straight for yourself. But I think this problem is going to be good for you as you look at those kinds of changes. All right. So 34. We've got 3 more to go. Okay, 34. We're going to solve this system using a substitution. Show your work. Friends, look at that. I have got decimals in it. Ugh, not really happy about that. Okay, that's okay. We're going to work through it. If you don't like the decimals, that's okay. We're going to use a calculator to help us along the way. But in order to use a substitution, I'm going to have to look for the smartest way, which is to go with the variable that doesn't have a number in front of it. That's going to be this y right here in that second equation. So I'm going to take that equation and I'm going to solve for the y. I'm going to subtract the 5.25x. But friends, be real careful. That leaves me negative y equals negative 5.25x minus 10. Then I want you to divide by a -1 on each of these terms. That gives me y equals 5.25x plus 10. Now we're going to take this and substitute it into the other equation. I'm going to use some of my colors here, so hang with me. I'm taking the first equation, and where there's a y, I create space here with the parentheses. Now I'm going to take this is what y equals, and I'm going to put that in the parentheses. Now let's solve. Notice that 2 is not just a 2, it's a -2. So we're going to have to distribute -2 there. That'll leave me with 4.25x multiplied by -2 gives me -10.50. Multiplied by -2 gives me -20, and that equals -44. Combine these two with your calculator. 4.25 minus 10.50 gives me negative 6.25x. Then you can add 20 to both sides. Leaves me with negative 6.25x equals negative 24. And then divide both sides by the negative 6.25. So that we get, friends, I just go totally old school on it sometimes and just use a for function for that kind of calculations. I get 3.84. Now remember, that's only half of the solution. You still have to go find y. But the beauty of it is we already have this equation for y. So let's plug in x for the y there. I'm sorry, let's plug in 3.84 for the x there. Create space. We'll put in our 3.84 and crunch it out on that for function. Sometimes I have my graphing calculator right real handy, and then sometimes I don't. So friends, I still will pull out that for function on my phone and make it work. Now, let's package this so that it looks like a good math answer. And that's what we're going to do. X and then Y. That's 3.84 and 30.16. And that's my solution to this problem, solved by substitution. Now, friends, I know I could have solved that on the matrix calculator, but there might be a reason why we wanted you to do it by substitution. Just a hint there. Okay, 2 problems to go. Let's look at number 35. Lots of good pieces in here, so I want you to make sure you're taking note. If you're says a factory can produce products, here's your profit equation. Look at that second equation. Second sentence. The production of y must exceed the production of x by at least 100 units. Write yourself an inequality here. The production of y must be exceeding, greater than, the production of x by 100 units. Okay. Moreover, production levels are limited by this formula. And we want to remember to use Desmos graphing calculator. Good thing we already have it pulled up. Let's switch over. Now, friends, on this one, it looks a little different because it's the Desmos graphing calculator. So remember that old Google Desmos matrix calculator? Now you're going to Google Desmos graphing calculator to be able to do it. I'll put it in the links too, so you have both of them, but just know that that's what you want to be using. Okay, let's get everything in here. We're going to just type them in as is, friends. We've got y is greater than x plus 200 or 100. And I can't see that, so let me zoom out a bit here. There it is. I'm just using that little minus there on your screen. There we go. That'll work. Let's do number 2 then. That's the equation, the inequality they gave us. X plus 2y is less than or equal to 1800. And again, I need to zoom out. Let me move that so you can see. So friends, what I'm doing here is I'm just clicking this minus, and that makes us zoom out. Okay. So click the little minus to zoom out so you can see all of your regions. Okay, so friends, I want you to see that triangle that we have going on here. See it? See it. Okay, now this one is the only vertex that did not give us a value. So check out Desmos. I know that on your graph, we didn't give you axes, and that's because it was so big. We didn't really want to make that, those numbers so big when we labeled it. But you can draw a sketch here. Okay, we are really looking for that triangle region, and I'm going to just sketch it because I want you to see it. But the most important part is I want you to label those vertices. Use your Desmos. Just hover your mouse over it. 533, looks like that's in a 1/3 thing. Oops, and a comma. And then I've got 63 and a third as well. So that's one vertex. And then go ahead and move your cursor up to the top one, that's 900. And then the one that's not labeled is the one that hits the y-axis here, and I believe that's at 100. Okay, now we've used our calculator. We've identified the vertices. Now, the beauty of the second part of this, friends, is we're just going to see which one of these maximizes the profit for us. So I'm going to switch back over so we have a little bit more space so that you can clearly see. This is a little bit of plug and chug. What do I mean by plug and chug? You're going to take the profit equation, which was 10x plus 26y minus 750, and you're going to plug in those vertices. So you've got 100, you've got 900, and you've got 533 and some change, 633 and some change. And all we need to know is which one produces the maximum profit and what is that maximum profit. So this is X, this is Y. We get to plug it in. 10 times 0, you and I know that's still 0. Then I've got 26 times 100 minus 750. So hopefully you're putting that in your calculator, and that gives you a profit of 1850. We're going to do the same thing for the second one. Plugging in 0 and 900. So I got 26 times 900 minus 750. Oh, by the way, 10 times 0 is still 0. So I get 22,650. And one more. So we're going to put in 10 times 533 and some change, plus 26 times 633 and some change, minus 750. Let's see what this one gives us. I've got 10 times 533 and some change. I've got 26 times 633 and some change. And then I'm subtracting 750. And it looks like I get 21,048 and 80 cents, roughly, give or take. So it looks like my maximum profit happens here. Maximum profit is 22,650. Okay. Where does that maximum profit happen? It happens at, or it happens when x equals 0 and y equals 900. All right. Friends, we made it to the last one. We've got one problem left. Let's look at this one. This is asking for what are the solutions to the quadratic equation. So this one looks like, I don't know about you, but I prefer factoring. So let's see if we can factor. I'm going to look at that first term and ask myself, what times what gives me 5x squared? Oh, I know that's got to be 5x and x. Now I need to say, what two things multiply to give me 6? So that's going to be 3 and 2. Now check your outside inside. 5x times 2 is 10x, and 3 times x is 3x. I need these to add to 7x, so that means the 3x would have to be negative, and so I put a minus here and a plus there. Now, to finish up, we set each of these parentheses equal to 0. And so I'll solve. And then you can divide by 5. And so x is 3/5. And over here, x would be negative 2. Now, if you don't see the factoring part, can I show you a little bit easier way? Just as we finish up, because I want you to have this in your toolbox. All right, I'm going to switch over to our graphing calculator. I'm going to erase what we had before. And I'm going to put in this equation, 5x squared plus 7x minus 6 equals 0. I want to take the equals 0 part off, friends. Now, zoom in so we can see. Do you see those places where it touches the x-axis right there? Do you notice those are the same answers we got? So wherever it touches the x-axis, that x value is our solution. So if you want to check yourself, or if the factoring really didn't make sense, feel free to use this one as well on the graphing calculator. Okay, friends, I'm going to link the Desmos graphing calculator, matrix calculator in the notes below. I'll also link part 1 and 2 if you need those. Thanks so much for for watching, and I hope this helps you on your final exam. Remember, keep it right beside you as you're working. Let me know in the comments if you have any questions. I'd be glad to answer those. Bye for now.